There are different methods to determine the size of an object, one of which is based on the amount of sunlight that this body reflects. Triton reflects a lot of sunlight, so it was difficult to estimate its exact limits. For many years, Triton was thought to be the biggest natural satellite in the entire solar system, even larger than Titan or Ganymede. Gerard Kuiper made the first attempt to measure Triton's diameter in 1954, calculating it at 3,800 kilometers. Subsequent measurements by other astronomers came up with values ranging from 2,500 to 6,000 kilometers, i.e., a diameter slightly smaller than the Moon, 3,474.2 kilometers, to almost half the diameter of the Earth. Before moving on, be sure to like or dislike the video so that we can improve them for you, the viewer. Plus, don't forget to subscribe to our channel by making sure to hit the notification bell so you don't miss any of our daily videos. For a long time, information about Triton's correct diameter and many other of its physical characteristics was kept a mystery, but this changed in the 1980s when the Voyager 2 probe managed to fly very close to this distant satellite in August 1989. The images captured by the Voyager 2 probe provided essential information that helped scientists define the exact diameter of Triton, which is 2,706 kilometers, once and for all. Since Voyager 2, no other spacecraft has been sent to visit this distant frozen world. However, the information provided by the only mission to visit this moon helped us determine Triton's diameter and revealed secrets of this natural satellite that we would never have imagined. One such discovery is that despite being a moon, Triton has a light and fragile nitrogen atmosphere and possibly has a liquid ocean beneath its icy surface. This has been corroborated thanks to the fact that different geological formations have been observed on the surface of Triton, which suggests that it has internal heat. In addition, cryovolcanism has also been observed. This type of cold volcanism can only be explained if, inside Triton, some type of heating could be expelling materials below its surface to the outside in the form of geysers. The presence of geysers in an icy body can only be due to something heating it inside. Usually this heat can be produced by tidal forces or by a rocky core with materials that radiate a lot of heat like the Earth's core. In the case of Triton, scientists believe it. The internal heating of Triton may be due to both tidal forces and a rocky core with materials that radiate heat. But if Triton's interior is warmer than the exterior, is there a chance that the ice on the outside will remain liquid? The answer is yes, indeed, because Triton's surface indicates a long history of melting. Models of its interior postulate that Triton, like Earth, consists of a solid core, mantle, and crust. Water, the most abundant volatile element in the solar system, makes up Triton's mantle, which envelopes a core of rock and metal. It is thought that there's enough rock in Triton's interior for radioactive decay to keep a liquid ocean beneath the surface to this day, similar to what's thought to exist beneath the surface of Europa and several other icy outer solar system worlds. This makes Triton one of the most distant bodies in the solar system where liquid water could be present. But if liquid water is beneath Triton's surface, could living things also exist? We'll only be able to discover this when we send a new space exploration probe to study this further. When will we send the next mission to Triton? It is not easy to visit the frontiers of the solar system. The Voyager 2 probe took 12 long years to reach this natural satellite since it departed Earth on August 20, 1977. The reason it took so long is that to reach the farthest corners of the solar system, spacecraft must travel hundreds of thousands, millions of miles into space. The technology for interplanetary flights of 40 years ago is not much different from what we have today, so traveling such great distances is still extremely difficult, especially when the destination is on the planet's farthest from the Sun. Traveling long distances requires vast amounts of fuel, but space exploration probes don't usually carry much fuel, which limits their acceleration. One way to solve this is to use gravitational assist, a method in which spacecraft accelerate by taking advantage of the gravity of massive bodies such as planets. This maneuver is used for spacecraft to acquire incredible speeds when they pass close to a massive object such as a planet, the gravity of which accelerates the spacecraft a little. However, this method is problematic because it can only be carried out if the spacecraft encounters a body during its journey. If it encounters nothing during its journey, it will not be able to use this maneuver. For this reason, the Voyager spacecraft was launched during the 1970s, when a very special planetary alignment occurred that happens approximately every 175 years. This alignment would allow the spacecraft to take advantage of the gravitational assistance of the four massive planets, Jupiter, Saturn, Uranus, and Neptune, allowing a small space probe with little fuel to visit all the outer planets and gain enough momentum to leave the solar system. This alignment occurred in the 1970s and is not expected to happen again until 175 years later. For many years, another space exploration probe was not launched to study Triton since reaching this distant world again would require a new planetary alignment. Without the help of the planetary alignment harness to take the Voyager probes, it would take several decades for a spacecraft to reach a natural satellite as far away as Triton. One solution to this problem is for a spacecraft to depart from Earth with much more fuel than the Voyager probes had. By acquiring great acceleration, it could reach a speed similar to that reached by the Voyager probes and thus reach Triton in just over a decade. However, the travel time is still longer than 10 years, which means that if a spacecraft were to take off from Earth today for Triton, channel members who are 20 years old would have to wait until they turn 32 to see the spacecraft arrive at its destination. Similarly, subscribers to this channel who are 30 today will be 42 when the spacecraft arrives at Triton. As you can imagine, 12 years is a long time, and that's one of the main reasons we haven't sent a probe to this moon again, because any mission would take more than a decade, even if it used a planetary alignment like the one used in the 1970s. In short, as the title of this video says, it is very difficult to get to Triton. However, it's not impossible. Currently, some proposals are being made to revisit this distant and cold world. Planning a space exploration mission for a world so far away that the travel time exceeds a decade is not easy. After all, it requires enormous planning and orbital calculations. But that has not stopped NASA scientists, and for some time now, new ideas have been proposed to revisit Triton. One of those proposals is Neptune Odyssey, a mission concept for a Triton-centric orbiter that will be studied from April 2021 as a possible central strategic NASA science mission. If the proposal passes all the filters, this mission will be launched in 2033 and reach the Neptune system in 2049. As you've just heard, even with modern technology, it would take more than a decade to reach Triton. How old will you be in 2049? Let us know in the comments. Two lower-cost mission concepts have also been proposed for the New Frontiers program. The first of these proposals is called the Triton Ocean World Surveyor. This mission would be launched in 2031 and reach Triton in 2047, while the second will be called Nautilus, which would launch in August 2042 and arrive at Triton in April 2057. Can you imagine that? 2057. How old will you be by then? Let's hope that you're still a fan of our videos no matter how old you are. Now we would like to know your opinion. Tell us, when do you think the next mission to Triton will arrive? Write us your opinion in the comments.